Hello, good afternoon. I'm waiting for all of you students to come up with the questions. We had a session on phenol and aldehyde. Today we can have questions on carboxylic acid, amines, and finally the portion on environmental chemistry. So the carboxylic acids are very less acidic compared to the mineral acids like HCl and H2, so forth. And they can be made more acidic by substitution of electron withdrawing groups like chlorine. One or more chlorine atoms will progressively increase the acidity of the carboxylic acid. The carboxylic acids can be easily converted to their derivatives like acid chloride, acid anhydride, etc., by suitable reactions. Students, we had seen the chemistry of
இந்த பட்டன் அழுத்தாம இப்படி எழுதுங்க சார்.
We have seen the chemistry of carbonyl compounds. This is a ketone, and this is an aldehyde. This is characterized by having two alkyl groups on the carbonyl group and hydrogen and an alkyl group in the carbonyl group. The properties are quite different because of the presence of the hydrogen atom. This molecule is very easily hydrolyzed to a reagent called tolerance reagent. Tolerant reagent consists of silver amine complex. Silver gets reduced to metallic silver, and the aldehyde gets oxidized to the corresponding carboxylic acid. We had seen a large number of reactions of ketones and aldehydes, and the further development of chemistry is having carboxylic acid you can see this is further oxidized compared to the ketone and the aldehyde. You have another oxygen atom between aldehyde and carboxylic acid. Here, you have another oxygen atom, but one of the R groups is removed. These are ionized to the corresponding carboxylic anion and proton, carboxylate anion and proton. And if water is present here, if the reaction is done in water, it would be RCO minus plus H2O plus the hydrogen, which comes as a proton from the carboxylic acid, gets the water protonated, you get H2O plus. These are much less acidic compared to the mineral acids like HCl, H2SO4, etc. Nevertheless, they are comparatively more acidic than compounds like alcohols and phenols, because the keto group is electron withdrawing and pushes the electron along the bonds and keeps this hydrogen delta plus, is oxygen delta minus. If you take this carboxylic acid and prepare derivatives where you add chloroacetic acid, the chlorine is electron withdrawing, it will pull the electron away from the OH group or the carboxylic acid group, and hence the carboxylic acid group will be more acidic because hydrogen will leave as a proton more easily. You can put it in another way. You have Cl, CH2. This O minus, which is formed by the ionization of this chloroacetic acid, this will be stabilized by the electron withdrawing effect of the chlorine atom. So chloroacetic acid is more acidic than acetic acid. If you add two hydrogens, two chlorines, you have two electron withdrawing chlorine atoms that will pull the electrons between O and H even further. Therefore, you'll find that the ionization of the H to H plus will be even easier and greater in magnitude. Therefore, dichloroacetic acid is more acidic than chloroacetic acid. If you have three chlorine atoms, now you have three chlorines pulling the electrons from the OH group. To that extent, OH group will ionize more and more readily. But trichloroacetic acid is stronger acid than dichloro, which is itself stronger than chloroacetic acid. In fact, trichloroacetic acid comes close to the acidity of mineral acids like HCl, H2SO4, etc. Now, the carboxylic acids because of this acidity forms ester with acid, concentrated HCl. The resulting compound This reaction takes place by first protonation. This is the ethyl ester of carboxylic acid. Various alcohols can be used to produce different types of esters. You can have methyl esters, you can have propyl esters, and so on. And you can also have, we have seen previously, esters with phenol. For this, the carboxylic acid is reacted with sulfonyl chloride or thionyl chloride, SOCl2. This converts the hydroxy group to the chlorine group. This compound is called acid chloride. This is reacted with phenol. Get R, CO, O. Instead of a alkyl group being attached with the oxygen atom, a phenyl group is now attached to the oxygen atom. So these are some of the most common reactions of the derivatives of acid, which are made into chloride, esters. You also have this is acetic anhydride. This is formed by reacting two molecules of acetic acid with a dehydrating agent, like P2O5. It can also be formed and take an acid chloride plus R, CO, OH. This will the OH will go to this carbonyl and remove the chlorine, and you get this anhydride. The anhydrides are also very easy to convert to the ester. Instead of using the acid and alcohol, you can use the alcohol and the anhydride. This reaction will be faster compared to the esterification with acid and alcohol. Now, in addition to these type of reactions, the carboxylic acid has a variety of other reactions where once the ester is formed, it can undergo various condensation reactions. So this carboxylic acid functional group is very versatile and can lead to a variety of organic compounds. Is the simple acetic acid. On heating, forms, this is done in the presence of P2O5, which is the dehydrating agent. This compound is called ketene. This also can be used to prepare esters. This is a very important method for preparing esters. Now, next we go to nitrogen compounds. There are two types of nitrogen compounds. One is called nitro compounds. In this you have both aliphatic and aromatic. Nitro compounds. Examples of aliphatic nitro compounds is nitromethane, CH3NO2, and nitroethane. And you can have 3-carbon nitro compounds. One is this is nitropropane. This is 1 nitropropane. This is 2 nitropropane. Aromatic nitro compounds are of greater importance because of their versatility. So many different aromatic nitro compounds can be prepared compared to the number of aliphatic nitro compounds. The aromatic nitro compounds, the most common example is nitrobenzene. And with this nitro group on the benzene ring, you can have dinitrobenzene, 1,3-dinitrobenzene. I am adding the nitro group at the 1 and 3 position, because once you have one nitro group, it's very electron withdrawing. The second nitro group will enter only the 3 position or meta position. So this is meta-dinitrobenzene. This is nitrobenzene. But by varying the conditions, And using a longer synthesis, you can prepare para-dinitro-benzene. Various other types of substitutions can be introduced. You can have this is 1,3,5 trinitrobenzene. This is called a TNT, trinitrobenzene. And this is very powerful explosive compound. And it is very commonly used in explosives used to bring down buildings and other important industrial establishments. The other type of nitrogen compound is the amino compounds. You have here again aliphatic. And PH3, NH2, C2H5, NH2. In addition to just the division of amines into aliphatic and aromatic, the amines are further divided into primary amine, secondary amine, and tertiary amine. This is the example of primary amine, amino group attached directly to the alkyl group. This is also primary amine. They contain NH2 group. If you have an amine where the NH group is connected to two alkyl groups, it also comes in aromatic chemistry. The aliphatic chemistry, when you have, this is dimethylamine. This is called second degree or secondary amine. Finally, you have this is called third degree amine or tertiary amine. So you have nitrogen attached to either one alkyl group or two alkyl groups or three alkyl groups, and these are in turn called primary amine, secondary amine, or tertiary amine. In aliphatic chemistry, amino compounds also, you have this type of distinction. Let us look at the simplest this is aminobenzene. This is called aniline, the simplest member. Simplest member of the aromatic amino compound. Here also, you can have a variety of amines with various substitutions. You have toluidine, where the methyl group is in the 4th position compared to the amino group. You can have 3-methyl-aniline, 2-methyl-aniline, etc. And this aniline, just like in the case of aliphatic compounds, they can also be attached to 1 or 2 alkyl groups. Already one of the positions of nitrogen is attached to the aromatic compound. So it is possible only to attach 2 more groups, either alkyl or aromatic groups, to get this is N-methyl-aniline. N-methyl-aniline. So this is a secondary amine. You can also have N-dimethyl-aniline. Just like in the alkyl cases, you have the disubstituted anilines. These amines are prepared by usually reduction of nitro compounds. The nitro compounds are prepared have alkyl halide, and you react it with under proper conditions. The nitro group acts like a nucleophile, substitutes the methyl bromide, removing the bromine as bromide ion. So this gives nitromethane. So a lot of aliphatic nitro compounds can be prepared by this reaction. Sodium nitrite is reacted with methyl bromide. This needs a suitable solvent where NO2 will become this is the nucleophile. Sodium plus NaO2 minus. So similar reactions can be done to prepare other alkyl nitro compounds. The aromatic nitro compounds are obtained by reacting benzene with mixture of nitric acid and sulfuric acid. both concentrated nitric acid and sulfuric acid. This will produce nitrobenzene. This is an example of a typical electrophilic aromatic substitution. When you react nitric acid and sulfuric acid is a stronger acid than nitric acid. It protonates the nitric acid. You get HSO4 minus, and the nitric acid is protonated on the oxygen atom. And this breaks readily to give a molecule of water, and this becomes NO2 plus. And this reacts with benzene. One of the double bonds move and gets attached to the nitro group. So this H is removed as H plus, and the ring becomes aromatic again. Here it is disturbed from aromaticity. Now it becomes aromatic to form nitrobenzene. This substitution is called electrophilic. Electrophilic aromatic substitution. We have seen this earlier in the reactions of phenols. So this is a very important type of reaction to form nitro compounds, aromatic nitro compounds. And this usually on reduction presence of hydrogen and nickel gets reduced to aniline. This is the most important way by which aniline is prepared in aromatic chemistry. The amines are very reactive. They are very basic. If you add it to H plus in HCl and sulfuric acid, say this amine is C6H5, NH2. This will become C6H5, NH3 plus. So this has a high basicity, and protons easily get attached to the nitrogen atom. Nitrogen atom is a lone pair. The lone pair is a point at which the H plus attaches itself, as I have shown here. Just like carboxylic acid, these amines also exhibit a range of basicities, depending upon the groups attached to the compounds containing the amino group. As an example, actually the basicity of the amine depends upon the availability of the lone pair of electrons. If the lone pair is more available, it will become a greater, stronger base. If the lone pair is pushed away from the nitrogen atom, the basicity will be lower. If you have, for example, paranitro-aniline, the nitro group is electron withdrawing both by resonance and by inductive effect. The nitro group takes the electron away this lone pair goes to the bond between the carbon and nitrogen, and this bond moves here, this bond moves here, and the positive charge will be taken away because now another bond has come here. The nitrogen will become positive. When the nitrogen becomes positive, it cannot react with acid. So basicity of the paranitro-aniline is much lower than basicity of aniline. You can have 2,4-dinitro-aniline that is even less basic. Because there are two nitro groups which pull the lone pair of electrons from the nitrogen. Therefore, the amine becomes very, very non-basic. The very important reaction of aniline is formation of benzene diazonium chloride. If you have aniline, reacts with sodium nitrite with HCl, dilute HCl, and sodium nitrite at 0 degrees centigrade, 0 to 5 degrees centigrade. This reaction is called diazotization. It changes the amine to diazonium chloride. This is a very important reaction in organic chemistry because the diazonium chloride can be reacted with a variety of reagents to make the substituted aromatic compound. For example, if you just heat it with water, you get phenol. You can heat it with cuprous chloride, you get aromatic chloro compound. If you heat it with cuprous bromide, you get aromatic bromo compound. You can have a fluoro compound, sodium fluoroborate. Diazonium chloride plus you just make a salt with HPF4 and then heat it, you get aromatic fluoro compound. Very few methods are available to prepare the fluoro compounds. This is one of the most important methods. Another very important reaction of benzene diazonium chloride is what is referred to as the coupling reaction. If you have this nitrogen phenyl NN plus reacts with the para position of the phenol. Called phenyl azophenol or phenyl azophenol. These azo groups are very important in making coloring compounds, which are soluble and which are referred to as dyes. In case the coloring compound is insoluble, it's called pigment. The solubility is controlled by this is called a coupling component. This is called this compound is called 2-naphthol. This is a reactive point, just like in phenol, we have the para position. 2-naphthol, this is the reactive position, because this is reacted with sodium hydroxide. become more reactive because it will form the sodium naphtha oxide. The hydrogen here will be removed by sodium hydroxide as a proton, and the 2-naphtha oxide is the reactant. This 2-naphtha, when reacted with, this is just for an example. This will produce you have the phenyl as a group. Reacts with this one position of 2-naphthol, and this reaction is called a coupling reaction. So the resulting compound does not have any solubilizing groups. This is called a pigment. If you have sulfonic acid group, this particular compound is called H acid. Notice it has a hydroxyl group and an amino group. These positions which are next to the hydroxyl and amino group can couple with azo compounds, phenyl, benzene, diazonium chloride. And you can also control this coupling. If you do this in alkaline pH, the coupling will take place ortho to the hydroxyl group. If you do it in acid group, acid condition, you will get the azo group on this position next to the amino group. So you can have two different azo compounds and couple it with different points. Also, please note that this compound has 2 sulfonic acid group. That means it's more solubilized, and the compounds, the azo compounds resulting from this is dyes. They are solubilized. They can usually apply to cotton or wool. Organic chemistry is also there's no person coming. Yeah, I have not come prepared to give a lecture. I have come prepared to answer questions. I couldn't get even one student. I think maybe because it's 4 o'clock. And no, thank you very much for listening to my lecture on both carboxylic acid and their derivatives, and also nitro compounds and amino compounds, which have variety of reactions and very useful industrially. Therefore, I thank you for listening to me. Hope you be able to find something useful from here and also for the examiners.